Welcome to the student of class 12. In the last class, I have discussed about the preparation and properties of alcohol. Today, I will discuss about the phenol. That is, how will you prepare phenol and what are the physical and chemical properties of phenol. You know the formula of phenol is C6H5OH. This is called phenol. How will you prepare phenol? First method, preparation of phenol. We can prepare phenol either from benzene or from chlorobenzene or from aniline. In your NCERT book, there are main 4 methods for the preparation of phenol. Number 1, from chlorobenzene. From chlorobenzene. This is very important method for the preparation of phenol. The name of this method is Dawes process. Dawes. In this method, chlorobenzene treated with NaOH, sodium hydroxide, fuse NaOH at 300 degree centigrade, 350 degree centigrade and 300 atm pressure to form sodium phenate plus HCl. This sodium phenate on acidification gives phenol. Here one point you remember that in case of alkyl halide, if we treated with aqueous NaOH, we can prepare alcohol. But in case of aryl halide, with aqueous NaOH we cannot prepare phenol, because aryl halide is less reactive than alkyl halide. That I have already discussed in the haloalkane and haloarine. Why aryl halide is less reactive? This is due to partial double bond character of the CCl bond and the less polarity of CCl bond, because carbon is sp2 hybridized. So a vigorous condition, high temperature and pressure is needed to remove the chlorine in place of ONA. This is the first method. This is known as Dawes process. Number 2, from benzene. Benzene reacts with oleum. What is the formula of oleum? H2S2O7 to form benzene sulphonic acid, SO3H. This is known as benzene sulphonic acid. This benzene sulphonic acid, when treated with NaOH and then hydrolysis, it forms phenol plus SO2 plus Na plus SO2. So this is from benzene. Benzene, when treated with oleum, it forms benzene sulphonic acid. This benzene sulphonic acid, when treated with NaOH, it forms sodium phenate. This sodium phenate on acidification gives phenol. Number 3 method, from aniline. This is also very important method. Aniline. You know the formula of aniline is in benzene ring NH2, C6H5NH2. Aniline, when treated with NaNO2/HCl at 0 to 5 degree centigrade, it forms benzene diazonium chloride, benzene ring N2 plus Cl minus. This is known as benzene diazonium chloride. This benzene diazonium chloride, when boiled with water, it forms phenol. This is very important method, and this reaction, conversion of aniline to benzene diazonium chloride, is known as diazo reaction. This reaction is known as diazo reaction. So from aniline we first convert into benzene diazonium chloride by the help of diazo reaction, which on boil with water gives phenol. Another method, this is very important method, number 4, from cumene. What is the formula of cumene? Isopropyl benzene. Cumene is isopropyl benzene. Say benzene ring CH3 CH3. This is known as cumene, isopropyl benzene. Normally, benzene when reacts with propene in presence of phosphoric acid, or benzene when reacts with N-propyl chloride in presence of anhydrous AlCl3, then cumene or isopropyl benzene is produced. This isopropyl benzene on oxidation in presence of air, it forms cumene hydroperoxide. Cumene hydroperoxide. This is known as cumene hydroperoxide. This cumene hydroperoxide on hydrolysis, it forms phenol plus acetone. This is the better method for the preparation of phenol, because by this method along with phenol we give an important byproduct, that is the acetone. So these are the four methods for the preparation of phenol. First is chlorobenzene by Dow process. Then from benzene when treated with oleum means pyrosulfuric acid, H2SO7, it forms benzene sulphonic acid, which on alkaline hydrolysis give phenol. Next, aniline when treated with diazo reaction, that is NaNO2HCl, it forms benzene diazonium chloride. This benzene diazonium chloride when boiled with water, it forms phenol. And last reaction is the from cumene. So these are the general. You can also prepare phenol from salicylic acid. This is another method. Number 5, from salicylic acid. From salicylic. What is the salicylic acid? Ortho-hydroxybenzoic acid. This is known as salicylic acid, ortho-hydroxybenzoic acid. This when heated with soda lime, it forms phenol. Plus Na2CO3. So this is also another method for the preparation of phenol. Salicylic acid when heated with soda lime, we get phenol. Now next, the physical properties of phenol. What are the physical properties of phenol? So next, physical properties of phenol. You must remember two physical properties. Number 1, boiling point. You know that like alcohol, phenol also can form intermolecular hydrogen bonding, as shown this. Say this is phenol, OH, this is another phenol, OH, this is another molecule of phenol, OH. Now this OH bond is polar, so there will be hydrogen bond between hydrogen atom of first phenol and oxygen atom of second phenol. This bond is known as hydrogen bond. So due to presence of hydrogen bond, phenol have comparatively higher boiling point than haloalkene, than haloarine. Similarly, phenol is less soluble than water, because it can form water, hydrogen bond with water molecule, but due to presence of large bulky phenyl group which has hydrophobic character, so tendency to form hydrogen bond gradually decrease. So like alcohol, phenol is not so much soluble in water, it is slightly soluble in water. What are the chemical properties? First we compare the acidic properties of phenol. You know that if we compare the ethanol and phenol, which is more acidic? Phenol is more acidic. Why? That can be explained by the resonating structure of phenol. If you draw the resonating structure of phenol, this is the resonating structure of phenol. Phenol have plus M effect. You have already known this. Now in this resonating structure you observe that due to resonance the pi electron density in benzene ring increase and O oxygen atom acquire partial positive charge. If oxygen atom acquire partial positive charge, then OH bond become more polar because oxygen pulls the bond pair electron of OH bond more tightly. So due to greater polarity of OH bond, it can easily release H plus ion. So it is acidic in nature. In case of alcohol, ROH, due to the plus I effect of alkyl group, it releases electron towards oxygen atom, making the OH bond less polar. So it is very difficult to release hydrogen atom. So alcohol is less acidic. In phenol, due to the resonance effect plus R effect, the oxygen atom in OH bond become partial positive charge. So the OH bond become more polar because oxygen atom pulls the bond pair electron more accurately. Due to the greater polarity of OH bond, the hydrogen atom can easily release. The acidic character of phenol can also be explained if you consider the stability of the phenoxide ion. Say this is phenol, when it release water, it form phenoxide ion plus hydronium ion H2O. Now if phenoxide ion is more stable than phenol, then reaction proceed in the forward direction producing hydronium ion, so it will be acidic. Now phenoxide ion is also resonance stabilized. If you draw the resonance structure of phenoxide ion, this is the resonance structure of phenoxide ion. In this resonating structure, there is only negative charge. There is only negative charge. Now you compare the structure of resonance structure of phenol and phenoxide ion. In phenoxide ion, opposite charge develop, positive charge on oxygen and negative charge on ortho and para position of benzene ring. So to make the charge separation, they attack each other. To make the charge separation, some amount of energy is needed. So phenoxide ion are in higher energy level. Higher energy level means less stable. But in case of phenoxide ion, there is only negative charge, oxygen atom does not carry any positive charge, so no energy is needed for charge separation. So phenoxide ion are in lower energy level. Therefore phenoxide ion is more stable than phenol. Due to greater stability of phenoxide ion, the reaction proceed in the forward direction producing hydronium ion, so phenol is more acidic than alcohol. Now acidic character of phenol increase if some electron withdrawing group are present in benzene ring. Say electron withdrawing group such as NO2, Cl, Cn. If these group are present in benzene ring, then acidic character of phenol increase because they withdraw electron from the benzene ring, making the phenoxide ion more stable. For example, orthonitrophenol is more acidic than phenol. Orthonitrophenol is more acidic than phenol. This is due to electron withdrawing effect of NO2 group. If it withdrawn electron from the benzene ring, then phenoxide ion become more stable. Due to greater stability of phenoxide ion, the acidic character increase. If number of nitro group increase in the benzene ring, then acidic character also increase. For example, picric acid 2,4,6 trinitrophenol OH NO2 picric acid. This is most acidic because 3 electron withdrawing group is present. Then ortho 2,4-dinitrophenol OH NO2 and NO2, which is more acidic than paranitrophenol, which is more acidic than orthonitrophenol, which is more acidic than metanitrophenol, and which is acidic than phenol. Here you one point remember, if electron withdrawing group are present in ortho and para position, then acidic character increase as compared to meta position. But here, why para-nitrophenol is more acidic than ortho-nitrophenol? Because ortho-nitrophenol can form intramolecular hydrogen bonding. Due to intramolecular hydrogen bonding, the hydrogen atom bonded with oxygen atom of NO2 group, so it cannot be easily released. So ortho-nitrophenol will be less acidic than para-nitrophenol. If electron releasing group are present in benzene ring, then acidic character will decrease. Say methyl group or OH group, if are present in benzene ring by NH2 group, they decrease the acidic character of phenol. In case of electron releasing group, the effect is more prominent in ortho and para position. So metacresol, this will be more acidic. Metacresol, OH, CH3, then paracresol, then orthocresol, and this will be more acidic than paracresol. So if and all these are less acidic than phenol. So this will be the order of the acidic character when electron releasing group are present. So this is very important. You must remember that when electron withdrawing group like NO2, Cn, halogen are present in benzene ring, then they increase the stability of the phenoxide ion, so acidic character increase. But if electron releasing group like alkyl group or NH2 group or OH group are present in benzene ring, it decrease the stability of phenoxide ion by releasing electron, so acidic character decrease. Now some important reaction of phenol. What are the if you notice the resonance structure of phenol, you find that in ortho and para position acquire partial negative charge. So phenol is ortho para directing group, because in the resonating structure ortho and para position acquire partial negative charge. Now pi electron density in phenol increase due to resonance, because the lone pair electron of oxygen atom is introduced into the benzene ring. So due to increase in pi electron density, the ring is activated. So phenol is more reactive than benzene towards electrophilic substitution reaction. Why phenol is more reactive than benzene towards electrophilic substitution reaction? This is increased because OH group has plus R effect. It introduced the electron density into the benzene ring. Due to increase in pi electron density in the benzene ring, the ring is activated. So phenol is more reactive than benzene. For example, phenol reacts with dilute nitric acid to form orthonitrophenol and para-nitrophenol. But benzene does not react with dilute nitric acid to form nitrobenzene. When reacts with concentrated nitric acid, it forms 2,4,6 trinitrophenol. This is known as picric acid. When reacts with bromine in presence of carbon disulfide solvent, it forms orthobromophenol plus para-bromophenol. But when reacts with bromine water, it gives a white precipitate of 2,4,6 tribromophenol. This is known as 2,4,6 tribromophenol. A white precipitate is formed. Some important reaction, another two important reaction of phenol. Phenol when heated with zinc dust. Phenol when heated with zinc, it forms benzene. It forms benzene plus zinc oxide. Phenol when heated with acetyl chloride, CH3COCl, it first forms phenyl acetate, OCOCH3, phenyl acetate. This phenyl acetate when heated with anhydrous aluminium chloride, it undergo rearrangement to form orthohydroxyacetophenone plus para-hydroxyacetophenone. This reaction is known as Fries rearrangement. This thrice rearrangement. Phenol, when oxidized by K2S2O8 part potassium part disulfate, it form benzoquinone. So these are some important reaction of phenol. With dilute nitric acid, it form orthonitro and paranitro, but when treated with concentrated nitric acid, it form picric acid, that is 2,4,6 trinitrophenol. With bromine water, it gives a white precipitate of 2,4,6 tribromo-phenol. When heated with zinc, it form benzene. When treated with CH acetyl chloride, it undergo acetylation because it is alcohol, it is acid, form a ester, OCOCH3, phenyl acetate. This phenyl acetate, when heated with anhydrous aluminum chloride, it form orthohydroxyacetophenol and para-hydroxyacetophenol. This reaction is known as price rearrangement. So student, these are some important reaction of phenol. Another two important reaction that I will discuss in the next class, that is Reimer-Teimer reaction and Kolbe reaction, and some important application of Kolbe reaction and the coupling reaction, that will be discussed in the next class.